So hello everyone. In this video, I will about magnets and magnetic material. So it's all about magnetism. So this is Cambridge Science, and this is year 5, which is actually grade 4 in Indian standard. So how exactly one should teach Cambridge Science and how one should enforce self-studying science in children. So I hope this video turns out to be an informative one as well as acts as a good revision video. So I'm going to cover everything that is related to the child's current grade level, and I'm not going to go in depth because we all know magnetism is a topic which comes in higher level, but that's the beauty of Cambridge, that they teach complex topics very easily and make it child friendly. So without wasting any of your time, let me quickly show you through the pages of this chapter. So here they're talking about magnets and magnetic materials. And since this topic was already introduced in year 4, that is grade 3, the child is familiar with the terms like a magnet has two poles, north and south. They are aware of like poles repel each other, unlike poles attract each other. So these concepts they are well versed with, and that is why they just uh, used a very simple problem to revise their previous concepts. So this is all about the spiral way that I always tell you. They always revisit the previous topics and then they move on to the next version on the same topic. So here they're talking about magnetic materials and which metals can be magnetic and which metals cannot be magnetic. So definitely the child can read this. There's nothing that I have to explain here. And how a magnet is different from a magnetic material is a very important topic, and I want to explain it to you. Since we are doing the topic of magnetism, I have written it as magnetism. So how a magnet is different from magnetic materials. So let me tell you all about a magnet first. So magnet is an object that has magnetic powers inside it, okay? It has magnetic powers inbuilt, okay? So we can say it has inbuilt magnetic powers. Which means that around this magnet, we experience a magnetic force or a magnetic field. Okay, so there is magnetic force around a magnet, which means that there is a magnetic field. I'll explain you what is a magnetic field. Whereas if we talk about just a magnetic material, so these materials, they respond to magnets by getting attracted to it, okay, or stuck to it. So this is my bar magnet. Then different types of magnet as per the shape and size. This is a bar magnet. Then we have a disc magnet also, and we have a horseshoe magnet, north, south. This is divided like this, north. This is divided like this, north and south. So this is a bar magnet. This is a horseshoe magnet, and this is a disc magnet. All right. So Let's start with the basics. When we have two like poles, north and north, the opposite ones are definitely south. Here, they are going to move away from each other, so it will repel, and this is known as repulsion. Okay, and if we have unlike poles, that's a north and south, they attract towards each other, and this is known as attraction. So if this part of the bar magnet is south, me what will this be? Yes, it's going to be north. If this is north, then this is going to be south. So this is the basic rule of magnets. Now, these magnets have a field around it. Like, this is going to act, the magnetic property of the magnet is going to be active only till a particular distance. And suppose if a medium, if we talk about field, I want to take it sports. Okay, so field sports. So different sports have different types of field. If you are playing a basketball, this is how the court. Yeah, if you're playing cricket, it's more like an oval, right? And if it's tennis, again, it's like basketball only. Uh, um, any other sport think of at the moment, I just think of these three. So these are the different fields for different sports. Now, can you see different shapes here, right? In a similar way, a magnetic field possessed by a magnet is very different, and I want to show it to you. So this experiment is very interesting. You can take some iron dust and a bar magnet and take a tray, put a cardboard down and throw the mm, iron dust. You're going to see something like this. All these iron dust, which is actually a magnetic material, it's going to get attracted to the magnet in the following way, which shows that the shape of the magnetic field around magnet is like this. This is how the shape of the magnetic field around a magnet looks like. Okay, so the iron dust is going to get scattered in this way, and this is the field. If I consider a magnetic material, so let's take an iron coin. Okay, we put this iron coin here, 1 rupee. If I place it here, will it get attracted to the bar magnet? No, because it is outside the magnetic field. All right, it's outside the magnetic field. So the force exerted by the magnet acts only when the magnetic material comes in the magnetic field area. If it is away from it, has no influence. Okay, now if I put this coin over here, if I put this coin over here, certainly it's going to get attracted and will come over here on the magnet. Okay, so this is how exactly a magnetic field looks like and how a magnet is different from a magnetic material. A magnetic material will respond to magnet's power. It's going to respond to the magnet's force and it will get attracted towards it. So now we know that this coin made out of iron is because iron is a magnetic material. So let's say this is the coin made out of a magnetic material. Do you think we will have any of these fields around this because it's a magnetic material? Will there be any magnetic field around this magnetic material? Can I draw something like this? Yes or no? We have never seen something like this happening. And if you ask me why, so sure. If I you ever bring if you ever bring two coins close together, do you experience any repulsion or attraction amongst them? No, never. But if I put a magnet over here, then certainly it gets stuck to this. Power is here. The magnetic force is in the magnet and not in the magnetic material. So I hope this concept is clear to you. Now we talk about strengths of magnet. All right, strengths of magnet. So as per the utility, the magnets are designed. So if we want to segregate magnetic materials from a trash can, I'm going to use extremely powerful magnet, which is going to attract all the magnetic materials, and it's going to leave the non-magnetic materials in the trash can. So this is my trash can. It has a lot of items over here. And then I take a big circular magnetic disc. I put it very close to it because I sensed it. Uh, the magnetic field is acting, right? It's very important. If it is kept far away, the magnetic field uh, is little away from the material and it may not attract it. So as soon as these materials come in contact with the magnetic field, it gets attracted, stuck to the magnets. And whichever items are left behind, they are again a design, product design that uses the concept of magnetism. So if you have any future in being a product designer, having such solid understanding and vision and creativity will certainly going to help you. And it's better that you start early and be aware of everything that is in your school. So this was about the strength of the magnet and how its application has been used, how the concept has been applied to this particular situation. Next is strength of magnet. Again, we are still in the same topic, that is strength of magnet. So if we say, um, I have two bar magnets over here, and the other is definitely going to be with you. Um, just imagine they have, um, it's in a different setup. This is, say, room one, this is room two. Okay. The reason why I'm doing it, because then they might attract each other, right? So I'm drawing the magnetic field of both the bar magnets. Now this is A and this is B. Can you tell me which magnet is more powerful and why? Certainly, magnet A is more powerful because I see a lot of magnetic lines, and it is extended to a wide distance. So this magnet is so powerful that even if a magnetic material is placed at a distance from it, it's going to attract it. Whereas here, I see weak lines of magnetic field here, weak magnetic lines over here in B. In B, we see weak magnetic lines, and also it is not widely spread, which means if an object is over here, it's not going to get attracted to it. But if the object is on the magnetic field at, say, distance of, say, 5 centimeter, because it is powerful, it's going to attract. Similarly, if we place this at a distance of 5 centimeter, because it's a weak magnet, this coin is not going to get attracted to this bar magnet. So this is how you can explain, and by that we are at the end of this topic, that is magnetism. I hope you understood well. You can rewatch the video. Now the homework here is, I want you to read the chapter 5.4 and 5.5, solve or just go through the activity questions and back questions, all right? And also go through the worksheets that has been to your from your school. That's going to keep you ready. It's going to get you ready for your exam, and you're going to pass your exam with flying colors. If there is any doubt that you come across, feel free to type down in the comment section, and I'm going to revert it back to you as soon as possible. That's the only way you can get in contact with you and raise your queries. All the very best, and happy self studying. Bye.